So this is the same circuit as in question 1 in this exercise series, but I asked you to do mesh voltage analysis. So for mesh voltage analysis, as you know, we have to identify meshes and then we label the mesh current. So this, I call it I1, then I2, and then on this mesh, as you see, there is a current source. So whenever you have a current source, which is not in common with other meshes, okay, so for example, the current source is not here, the current source is here, then I can basically label that mesh current based on that current source. In this case, I mean, I always go with the clockwise. So if I consider clockwise, so the amount of mesh current would be negative 2ix. Hopefully everybody agrees. So 2ix is going this way, so negative 2ix is going that way. So that will be the amount of the mesh current. Okay, so now that said, let's write the KVL. So for mesh current, we write KVL. So KVL at the mesh I1 related to I1. So I go this way. So 1 times I1 plus 3 volts. See, we are writing KVL. So I'm adding up the voltages. So this one is RI, 1 times I1, and then I come here. The voltage here is, I hit the plus, so it's 3. And then I go here 2 times. Oh, sorry. Okay, sorry. So I1 plus 3 plus 2 times the current of 2. The current for the 2 ohm is I1 minus I2. I1 minus I2 equals 0. Then KVL at second mesh, 2 times, what's the current of 2 ohm? It's I2 minus I1. 2 minus I1. And then I come here, 2 times, again, I2 minus this current, which is negative 2x, basically, minus negative 2ix. And then plus 1/3 times I2 equals 0. Okay. And then because of the, and okay, so on this, that mesh, I don't have to write, I don't need to write any KVL here because already, because of this current source, we already labeled it, okay? But the only thing that I have to do, because this is dependent, I have to write an equation that somehow relates the dependent source, the dependent value to other values. And in this case, basically, we know that, okay, Ix would be Ix here. The current that is going this way is this current minus that current. So that current is minus 2Ix minus I2. Okay, everybody sees that? So Ix is going this way, and then negative 2Ix is going that way too. So this minus I2 is equal to Ix. So that gives us one equation. So 3Ix equal to negative I2. In other words, Ix is minus 1/3 of I2. Okay, now I can replace Ix in the other 2 equations. And if we see somewhere, and then we have 2 equations, 2 unknown, I1 and I2, and solve it. Now, also, let's simplify the first equation. So from the first equation, I get I1 and 2I1, so 3I1. And then minus 2I2 equal to negative 3. So that's my first equation. So for the second equation, I have Ix. So I use this Ix here to replace that, and then I get the second equation. So let me simplify it. 2 I2 minus 2I1 plus 2I2 plus 2 times 4 ix, but ix is minus 1/3 of I2 plus 1/3 of I2 equals 0. So that gives me negative 2I1 plus 2 plus 2, 4. And then here we have minus 4/3 plus 1/3. So let me add the minus 4 plus 1. 1/3. So let me double check my math. Okay, so this is 9. This is 8 plus 9/3, which is 3. Very good. This is 3. So the whole thing here is 3 times I2. Okay. I just added them up, equal to 0. Okay, so that's the second equation. Okay, so I can do two things at this point. So if you want to, let's practice putting in a matrix format. I1, I2 equal to this. So the first equation, 3I1 minus 2I2, 3I1 minus 2I2 equal to negative 3. Second equation says negative 2I1 plus 3I2 equal to 0. So that's a matrix representation, and then we can solve I1 and I2. Or you can just, because just two equations, easy. You can find, for example, from here, you say, okay, 2I1 equal to 3I2. In other words, I1 is 3/2I2. And then you put it in the first equation and you find it. Okay, so either way, you're gonna calculate that I2 is minus 1.2 amp. Then I1 is 3/2 times I2 gives me minus 1.8 amp. And Ix, we were supposed to find Ix. Ix is minus 1/3 of I2. Calculate that, you get minus 4. Okay. Okay. Now I can continue and calculate like all voltages, etc. If the problem wants you to do so. But also I remind you of, we did the same problem in question 1, and you see that we got the same Ix as 0.4 amp. So this was the node analysis that I did, and then we did now the mesh analysis, and we got the same thing. Okay, so in this case, I would say at the level of doing the math, it was similar for both node and mesh. So there is no preference on one over the other in this example.